Hi, I'm Tim Comperta, and I will be instructing you how to use my 8 puzzle solver so that you can learn about search algorithms. First off, we're going to download the file. In this video's description, there will be a Google Drive link. And you'll want to click that link, and this will open a new tab with the Python file needed to run the code. You'll need to click on this new tab if the page doesn't automatically flick to it. And on this page, as shown here, is the Python code. And so in order to download it, you're going to click this downwards arrow that's pointing to the Smash to you. It says download if you hover over it. Then likely it might tell you that you might need to keep it or whatnot. Or sometimes it might just download. Or you'll need to click save if it says run or save if you're on Internet Explorer or Firefox. Alright, from there, you're going to go to the downloads folder. So you'll click the file system, and then you're going to go to downloads. And so this should pop up as one of the most recent files. Or if you're using Google Chrome, you can always just click run here. So from here, it pops up with this prompt. And it'll ask you, which difficulty do you want solved? Enter G for goal state, enter E for easy state, M for medium state, or H for hard state. G, if you type G, you will get the goal state, which is the state that essentially the board is trying to achieve. And so that's used to show that algorithms can recognize that they're at the right place. You'll type E for easy state, which is a state that's fairly easy for the algorithms to solve and doesn't require many moves to get to the goal state. Or you can type M for the medium state, which requires some more moves to get to the goal state. Or you can type H for a hard state, which requires a lot of moves to get to the goal state. Then, after that, you'll press enter to continue. So we're going to press H and enter. So then it's going to pop up with another prompt. Which search algorithm would you like to use? Enter BFS for breadth first search, which is a type of algorithm that searches by all actions available, and then from there, each action it searches through those actions and uses a sort of queue in order to go through each one. You'll type DFS for depth first search, which picks one action from every available action and just follows that until it reaches a blank state, or it hits the goal state, or it just ran through enough iterations that it can't go back, so it goes all the way back. Or you'll type UCS for the uniform cost search, which is which searches through actions and based on their overall cost. And however, if every cost is equal, then it's just as good as breadth first search. You'll type greedy if you want to use best first search, which bases off the cheapest current move. However, in this example, we're going to be using which has the smallest number of tiles out of place. Or you can type A*1, which uses the smallest number of misplaced tiles plus the overall cost of actions. So it's kind of like a combination of our UCS and our greedy search. And then A*2 uses a different heuristic, which it uses the sum of the amount of moves it takes for each tile to get to its goal position, otherwise known as Manhattan distance, along with the sum of the total overall cost of actions. And then press enter when you decide which one you want. And we're going to do greedy search for this one. And so here it shows off every single state it goes through, and then it finds its answer right here, and it'll tell you how long it took for it to search through the hard state. And there you go. That's all. After all this, I hope you understand how these algorithms work, and with a little bit of knowledge of Python and data structures, you too could make something like this.